right, so we're going to be looking at Newton's laws of motion. So what are Newton's laws of motion? Newton's laws of motion describe forces and how they explain motion. So first we're going to look at what is a force. A force is a push or a pull. We've talked about forces, we've talked about free body diagrams, and now we're going to start to use some of that information to see what's actually going to happen when those forces are equal, when those forces are not equal, okay, or balanced or unbalanced forces. Okay. So the first law we're looking at is Newton's first law. If there is no net external force, so that means the forces are balanced. So in our free body diagram, the up forces are canceling the down, the left forces are canceling the right. What happens? So if there's no net external force, if all the forces balance each other out, an object will move at a constant velocity. Okay? So if there's no friction to slow something down that's sliding along the table, it's just going to continue to slide at a nice constant velocity. Most often we use examples for outer space because in outer space you're not going to be sliding along the surface, you're just going to be moving through space. Okay, so if you're moving through space at a nice constant velocity, you're going to continue to do so. You don't need anything to keep propelling you, you're just going to keep floating off. Okay. However, your velocity doesn't have to be some actual number, okay? It could be 0. So sometimes you see it written like this. An object in motion stays in motion, and an object at rest stays at rest, unless acted upon by an outside force, okay? And when it talks about in motion, stays in motion, it means it stays in motion at the same constant velocity. It doesn't speed up or slow down either, okay? So what does this mean? It means when the forces are balanced, an object will continue to not move, or if it's already moving, it will continue to move in a straight line at the same speed. We call an object's tendency to maintain its current state of motion inertia. Okay, so we call the tendency to continue doing what you're doing, either moving at a constant velocity or not moving at all, we call that inertia. Therefore, Newton's first law of motion is also referred to as the law of inertia. All right, we're going to go ahead and look at demonstration number 1. We're going to have a car with a penny on top of it, okay? We're going to see what happens. That car is going to be going at a nice constant velocity once it's down here on a nice flat surface. We're going to say friction is minimal, so it's moving at a pretty constant velocity. And then it's going to hit a book. We're going to look at what happens, and we're going to look at how Newton's law explains this. Okay, so what happens to the penny when the Matchbox car hits the book? Well, what happened? Well, the penny continued to move. It flew off over top of the book. Okay, why does this happen? Well, the penny was on top of the car, and the car and the penny were both moving at a nice constant velocity. So they were an object in motion, they wanted to stay in motion. Then the car hits the book. There's a big outside force acting on the car, so the car stops. But the penny's an object in motion, wants to continue to be in motion. So it does. It continues to be in motion and flies off the top of the car. So the penny was an object in motion, so it stayed in motion. Okay, it flew off the top of the car. Using this demonstration, explain why it is important to use a seatbelt when driving in a car. So if you're in the car and unfortunately somehow you hit something, okay, if you're not wearing a seatbelt, you are an object in motion. You're in the car that was moving. So you're going to continue to move forward, okay? And you don't want to do that because you don't want to be hitting the windshield in front of you or the steering wheel, okay? So therefore you want to wear your seatbelt. Why? Because now you're kind of part of the car, okay? So when the car hits something, that force brings the car to rest, and you're attached to it by the seatbelt, so you're going to come to rest as well. You're not going to run up and hit the windshield. All right, so our second demonstration, we're going to place a note card on top of a cup, okay? Then we're going to put a penny on top of the note card, and we're going to flick the note card out of the way with our finger as fast as we can, and we're going to see what happens. All right, so what happened to the penny? Well, the penny didn't fly off with the note card. The penny fell straight down. Okay, so why was this? Well, the penny was at rest. It was on top of the note card. It was not moving. So it wanted to stay at rest. So despite the fact that I flicked the note card, the penny stayed where it was. Now, it can't stay vertically where it was because of gravity, but horizontally it stayed where it was. And then when the note card's no longer there, gravity takes over and it falls down, but it fell down directly below where it had started. The penny was an object at rest, so it wanted to stay at rest. So it stayed right above the lid or the top of that cup, and then eventually fell into it. So using this demonstration, explain the trick of pulling a tablecloth from underneath a set of dishes. Okay, so a tablecloth, you can pull it out from underneath the tablecloth out from underneath the set of dishes, and the dishes stay where they are. Why? The dishes have inertia. Okay, they are objects at rest. They want to stay at rest. So they're going to stay where they are, okay, unless acted upon by an outside force. All right, here, we'll get here. So we're going to slide a piece of paper across the desk, okay? So here, you can slide a piece of paper across the desk. All right, not too bad, okay? Then we're going to slide a stack of 4 science books. All right, now here's my stack of 4 science books. Slide those across the desk. All right. Which object was more difficult to move? Okay, obviously the 4 science books. Why? Okay, well, they have more inertia. Okay, they have more inertia. So what is inertia? It's an object's tendency to maintain its state of motion. So if you're at rest, you want to stay at rest. What gives these books more inertia than this paper? Mass. The more mass an object has, the more inertia it has. Okay? Mass is the measure of an object's inertia. Inertia is the tendency of an object to stay at rest. Therefore, which one has more inertia? The books. Okay? What measures an object's amount of inertia? Mass. The more mass you have, the more inertia you have. So the more massive you are, the harder it is to get started moving if you're at rest. The more massive you are also, the harder it is to come to a stop. Okay, so these semi-trucks out in the road, it's not easy for them to come to a stop. You want to give them space. You don't want to cut off in front of them and then put on your brakes, okay? Takes them longer to stop. Why? They have more inertia. They're more massive, okay? They want to stay moving. Which object would have more inertia, a bus or a bicycle? A bus. Why? It's got more mass.